Hey, welcome to our talk, A Visit to Our Armory, Crafting Your Own Combat Hardware by Luis Ramirez and Mauro Eldridge from DC5411. Before we start, we will make a really brief introduction about ourselves, the speakers, and about the topic of this talk. Well, I'm Mauro Eldridge, I'm an Argentine hacker. I'm the founder of the VCA and DC5411, which is the DEFCON group for Argentina and Uruguay in South America. I spoke at different events in the past, including DEFCON, EC Council Hacker Halted, and a couple of more events around the world. And I'm really happy to be here today at ROOTCON Philippines because it's the very first time speaking for this country and this audience. So we are really pleased to be here. Now my co-speaker Luis is going to introduce himself. Please, Luis, go ahead.
Thank you, Mauro. Hello, everyone. My name is Luis Ángel Ramírez Mendoza. I'm working on security hardware engineering in BCA, member DESCON Group 5411, speaker in DESCON, Dragon Heart, PostCon, Texas Cyber Summer, Grey Hat, beside Newcastle, YASCON, beside East Lavant, Honeycott, Coesi, and ROOTCON.
Okay, thanks, Luis. So now, going to the talk topic, this is one of our talks, which is actually a chapter of an episode, we can say, of an entire series of talks, which we call A Visit to the Armory. Our armory is basically our repositories containing all sorts of weaponized domestic hardware. It's purely oriented to hardware hacking. And this hardware is mostly intended for red teamers and infiltration teams and infiltration exercise, red teaming exercise, and all sorts of physical offensive exercise. So you can find a lot of really cool gadgets there. All of them have open source versions. And you can find bad USB power banks, speakers, keyboards, which are bundled with an hardware keylogger. All of them works as bad USB. We even have an entire bad USB framework which features a lot of access methods, a lot of attack vectors. All of them are available on our GitHub, which will be disclosed at the end of the talk. It will be shared there and you can have access to the entire repositories. Obviously, you will be free to clone and to create your own gadgets. And we are really looking forward for that. So if you have any project based on one of our projects from the Armory, we will be more than happy to take a look at it. So today, and obviously just for a matter of time, we can show all of these projects that were listed here. But today we will present 3 of these. One of them are really new. A third one, it's actually something which is in development, so it's still not released, but we're going to give like a sneak peek. We will see how to build smart movement sensors, again with open source hardware for all 3 projects. The author charts, which should not be confused with jammers or signal jammers or something like that. It's the author. We will see the difference in a few. And a surveillance suite, which is the in progress project we are having, the in development one, which tries to build open source cameras with different smart features. So we can take a small look at what we have here. All of these projects are not finished. As you can see, only one has a case. The other ones are just raw, only the components. This is intended for you to see that we are using real cheap hardware and some real simple and easy to acquire hardware. So even newcomers or experienced users can take a hold of this talk and say, okay, I'm going to jump into hardware hacking, or I am experienced hardware hacker, but I'm going to do something different today. So do not be afraid. These are pretty approachable projects, as you can see here, and we will try to discuss them, to share them in the most simple and friendly way for you to better understand it. All of these projects, as I said before, are open source. You can visit our GitHub here and see all of our open source projects, not only on Dash Armory, but on DC5411 user on GitHub. And obviously, feel free to do your own versions and to your own spin-off, to do whatever you want with it. Let's start with the sensors, the first part. So for the hardware, we will need some really easy to get pieces and really cheap, by the way. We will need a popular ESP8266 board, any standard infrared sensor, pick the one you like most, 9-volt battery, or in case you want to build something with a higher budget and more bulkier, you can pick up a power bank, a portable battery, but you will be using more than one sensor, so this can definitely rise the price up. A power switch and a disguise case, which can be a 3D printed one or an existing object like an electrical box. The point here is that this hardware will be used on physical pen testing exercises or red teaming exercises, so creativity here is a must and it's definitely a bonus. So try to use your imagination on where is the best spot to hide one of these sensors. Now, in case you want to add these sensors to certain surfaces, you can use any adhesive patch or even double-faced tape. We made our test with double-faced tape and it worked like a charm because it's pretty lightweight. Now, if you want to add a power bank here, I really discourage the use of anything adhesive. The weight will carry it down definitely. For the software, we have you covered. We have our own firmware, which is again open source, and the C2 server, which is written in PHP, uses MySQL, and uses our own web application, and all this can be Dockerized if you want. Now for the client, we have you covered too. We have a web application, which is the thin client, and a thick client, which is a mobile APK, in case you prefer it. Now let's take a look at the schematic. This is pretty simple. This is how almost any infrared sensor is connected to this kind of board. And now you may ask, okay, why ESP8266? Well, actually, we need the Wi-Fi enabled capabilities of this board for the next step. There are a couple of things that you must have in mind before using the sensors. The sensors will definitely need a way to communicate, so we will use Wi-Fi. This is why we have chosen ESP8266. Depending on the task, these operators, physical pen testers, red teamers, can either use a phone as a hotspot to share its LTE connection, or they can use a portable hotspot device for a longer coverage. Using a phone, maybe it's not the best way. If you're carrying it with you, you will probably run into connectivity problems if you walk away a long distance from the sensors. Also, depending on the building layout where you are pen testing, you can have definitely connectivity problems, for example, on older office blocks. Now we are trying on a new feature. We are trying to integrate SIM 800L, which provides us with a SIM card reader, and obviously by providing a 4G enabled LTE SIM card, we have the chance to use that connectivity. But by the way, we are just still researching this topic, so we have used SIM 800L before on different projects, but never on this kind of hardware. So it may take a while before we release a version that might feature it. And once again, we're still researching it. Now, both the sensors and the phone will interact via the C2 server, which can be located outside the premises on a Docker container, or if you have a phone which is capable of running a web server and a small database, well, you can have it in a portable way too. Now, whenever something alters the sensor, it will trigger a really primitive reaction. The sensor will notify you with a push notification, to your mobile phone in case you're using the APK, or it will turn itself in a notification for your browser if you're using the thin client. So you will see in a graphic way that something went wrong with and on which sensor this happened. Now, as you can see here, the database connection is quite simple. MySQL is not even mandatory. We have tested this with SQLite. So we can even reduce it further and make a way more minimalistic application for this. Again, we're just making the communication pretty straightforward and simple with the database backend. And you can browse it with even the simplest tool like PHPMyAdmin, and you can see that it's a quite simple database. Again, SQLite will work like a charm here too. Now, our firmware does something quite different than a common sensors firmware. The only thing here is that it will walk back and forth to the C2 server to communicate things, but outside of that, it works like almost any other sensors firmware you can find out there. So it's quite small, it's quite simple, and it just gets the job done and nothing else. This is our thin client for on a desktop browser. In this case, this is in Spanish, but it's quite intuitive what it says. Sensor 1, it's deactivated, and so on for the 2, 3, and 4 one, and the reset button. Now, this is the same client located on a mobile phone, viewed on a mobile browser. Again, this is exactly the same. You can reset them using this button. So if anything happens by accident, or if anything happens and you need to reboot the sensor, you don't have to access physically to it. You can just send the reboot command from here. Now, this is what happens when all these sensors are activated. An alert will be triggered, and one of the best advantages we have here is that you can programmatically alter this firmware to do whatever you want when a sensor is activated. For example, in our case, we use a feature that just gently makes the phone vibrate, but on a gently way, so it doesn't quite make a lot of noise. So it will subtly warn you that something went wrong. But you can tie this to almost any event, any custom event you want. So again, play with your imagination. Now, this is the thick client in case you want to use it. Obviously, it will look more raw than the other one, than the web one, but nevertheless, it works the same way, and it has the same reliability. The final product, without case, is this one. It's quite small, just compare it with the size of the hand and the phone. The quality is not the best because this is a photogram of a video. Now, this is a better looking picture. As you can see, this looks like quite simple. This is one of the first prototypes we have. We still have to make it smaller to make it more minimalistic too. Now, what are the advantages, before we jump into the demo, of using this over a common sensor? Well, the first one is pretty obvious. This is open source and affordable. If you want to buy already made commercial sensors, it won't be as cheap as this. Obviously, this is scalable and extensible. You can modify the firmware, you can modify the client application, the C2. So we have built 4 sensors by default, but you can add as much as you want. This is your best your best approach. You can even group them and say, okay, this instance is for the sensors on the east, this other instance will be for sensors located on the west. So no problem on that part. Now you will have also a smart, simple, and intuitive user interface. Again, you are using PHP MySQL and PHP MyAdmin. What could possibly go wrong? You are using something on the client side, right? You're using plain HTML with some CSS. You're not having to learn React. You don't have to learn some dark and really extensive framework. It's just plain HTML and PHP. You can modify it as you wish. And now, something that I subtly mentioned before, you are not tied to a single vendor lock response. For example, if the sensor is disturbed, a vendor lock response will be to ring a bell, to sound an alarm, to send you a notification on a highly specific application issued by the same vendor. But here you can trigger any response. You can add custom hardware like an Arduino or custom software in order to make these things act on a different way, more suitable for your needs. So, having said this, I think it's time to jump into the demo. This will be quite simple. We don't have quite a lot to show, but the sensors are working. All these sensors, which are again caseless, are placed here, and now Luis is going to fist bump them in order to make them react. As you can see, this is instant. There's almost no delay. This is pretty cheap hardware. You can tie this to any event, as I said before, and now you can say, for example, okay, once a specific sensor is disturbed, do this. But when all of them are disturbed, do that. So this is one of the strong points on using this open source affordable hardware. So now let's jump to a little bit more complex topic about the author charges. Now, before we start, I know this may be a little bit more complex, as I said before, I want to explain the difference between a signal jammer or a Wi-Fi jammer and the author. We are not going to build a jammer. We are not going to physically attack a network. We are not going to electronically attack a network or anything similar. What we are going to do is a de-authing technique, which is basically sending the auth packets on an indiscriminate way to almost all the hosts on a network. So we're going to use a firmware provided by a third party, by another person, which specifically asks people to do not confuse jamming with de-authing. So this is why I wanted to make this clarification. Now, Professor Luis is going to share with us a little bit more about this charge. So please, Luis, go ahead.
Thanks, Mauro. So the next artificial way are going to short Wi-Fi that charger. In order to build this device, you need a filing component, including both software and hardware. On the hardware side, we need an USB into C6, an USB power bank, a power switch, a cassette 3D print, which is optional and not shown in the install, adhesive patch, or any other adhesive compound. Now, on the software side, we'll need one of the filing to staining. SPG Home firmware. This is the classic one, which works perfectly fine out the boss bed, provide pretty much the file item and configuration command we was set up. TCA firmware patch. This is a modified firmware patch build, which provides some extra drilling specific capability like milking inside from popular national ASP. Regardless of your choice, you will be able to be the chart and lesson basic feature. To run the software, you will assemble new Arduino ID so you can pair firmware to ASP82C6 device. This is a width of the classic firmware, bringing the original order. is bring or CC postpone and will allow you the app Wi-Fi device. So what is the app? We'll explain it simple. The app for the authentication attack. This is an attack than the current Wi-Fi negotiation duping the line between two devices, say for example and cell phone and the router. This should not be can you with jamming. The Wi-Fi protocol contains the provision for the authentication frame, setting the frame for the access point and station is the way of disconnecting a specific device. Any attacker can spoof and the authentication firmware and send it the router with and fake MAC address, disconnecting a suspect victim. This attack can be carried out with the easy to graphical web user interface. The firmware with Adobe Key scan for available access point, provide and list and load the attacker to schedule a specific attack routine in the an interactive way. Here we have an sample of the most popular attack, the bacon flu and the Delph attack. The first and is named Seegers and Flow, which meant massive sending requests. In this case, and charger will flow the network with weekends, which are Wi-Fi authentified. For adapter list on the third menu. This will send an enormous amount of beacons, which translate into a lot fake Wi-Fi the router listing in your device interface. This can lead to confusion on the disruption of normal operation depending on how it the current. The second attack in the Delph which we will explaining before. An attack sent and the Delph frame which spoof MAC address, which belong to another which device. The router receives in authenticate the victim instead of the attacker. When coordinated, this attack can effectively interrupt normal operation for given victim. This is the final product with the Dream Print case, which is still under development. It is lightweight, small, and silent. This is adhesive. You can slide, deploy this hard virtually anywhere, creating chaos in makers of seconds, while making it hard to find. From an operated point of view, this tool shines the way some critical penetration testing routine exercises are carried out. As you can see here, the device is pretty to laptop. The sizing is pretty comfortable to be boot, hidden somewhere, and to also feature a good battery which will provide power to display for a good number of hours. Here a demo. Mauro will make some comment about it.
Okay, now it's time for a demo. Thanks, Luis, for the briefing. The objective of this demo is to show how we can disconnect a alleged client, the one on the right, from the Wi-Fi network and start creating mess and chaos with the Wi-Fi clients here. We will connect the attacker laptop to our device, to the charge. Now we will be greeted by the Space Homes firmware. This is not our firmware. Our firmware is just a patch that adds local and national SSIDs, which you can find them like the street free Wi-Fi and the coffee Wi-Fi's around here. So this will only be used for when you want to attack by creating fake APs. But it won't affect the basic firmware created by the Space Homes, which is actually a great firmware. Now the victim on the right is connected normally, and we will start sending the auth attack here, and then we will send a beacon attack too. So the idea on our firmware, on our patch, is to add like localized versions of the access points, which can be found in the wild here in the streets. But also, we have added some new features because when running this original firmware, sometimes we run into certain softlocks. So we have rewritten certain smaller parts, but actually most of the job remains the same. This is a really great tool if you want to start playing with Wi-Fi deauthing and small Wi-Fi attacks. I really recommend it, and it's pretty cheap to set up. So now this computer will start experiencing problems because we are obviously going to flood it with certain requests. Now you can see that it starts to fail. Now it will have certain problems loading up YouTube because we are still sending this packet flooding. If we stop it, the connection will eventually recover slowly, which can be used in red teaming to trigger a support response. Let's say that you want somebody to move to a rack where the access point is located. Let's say that you have the IT guy to climb into a table or into a chair to locate that really highly placed router or access point to see if he can reset it. Try to use your imagination again. What happens if you start messing with the Wi-Fi or hotspot or access points in a systematic way? You will sooner or later make somebody walk to it and try to see what's going on. So again, if you combine these simple tools with a little bit of psychology, with a little bit of social engineering, with which almost any physical pen tester or red teamer should have, you will have a really nice time, a real nice time. So once again, we start sending this attack and the machine is absolutely locked out of accessing. Remember, the idea here is not to cause damage. You don't want to cause damage. What you want here is to bring up certain attention. You want to get attention on a certain point. You want to make your exercise easier. This is why we came out with this with a power battery to make it portable. Okay, time to move on. So what are the advantages over a classic deployment model? In this case, we are being battery powered, so we are making it portable, as I said just some seconds ago. This custom firmware adds certain translations, common local SSID names, and simplifies certain operations, but once again, most of the firmware is left untouched. Now, if you have any custom discrete case, again, 3D printed or something, something existing object like electrical box, a fake vent or whatever, you can deploy this on a really creative ways. And also adding adhesive patches or double-sided tape can make this object really hard to be seen, to be detected, and also try to use your imagination again. What happens if you place this object in a really weird place? It will still cause damage and it will be really hard to be located, or at least it will be really hard to be dealt with. Now, this is a standardized size which we are trying to maintain across all our combat hardware. It's used to disguise this charge. Now, try to picture if you try to use this in a fake wall socket or under that desk or under a chair taped, right? Or for example, inside a closet or wherever. It will be really hard, at least on the spot, to be dealt with. And that's one of the advantages here. So now, moving on to the next part, we will talk a little bit about surveillance. This is a small project which is still being developed. We still have a lot of things to do, but we still wanted to share it with you today. So let's get to it. So for this part, you won't need real complex hardware or anything expensive, but you will need something different this time. We are using an SP32 cam, an USB power bank, or a 9-volt battery in case you prefer, an infrared sensor, which it's optional in this case, a power switch, a case, which can be again 3D printed or something to conceal this with, this is optional, and an adhesive patch or double-sided tape, which again is optional. And for the software, this time we are going pretty minimalistic. We are going to use our own firmware and Flask, a Flask application on Python for our C2 server. This is the basic product outline with its 3D printed case. As you can see, we are using something really simple here. This is the C2 server, which is the application. Again, using Flask, which turns this to a real basic thing, not real complex. As you can see, we have just a few endpoints. The application is not big at all. And we have implemented a recording script using NumPy and CV2. Actually, the idea here is not only to record video of this camera, but also to take specific screenshots in case you need them. That's the idea, to have both screenshots and recordings. As you can see, so far so good. We were able to make a lot of screenshots and captures over the time. These camera things works on a real similar thing as something that you have seen before. The sensors. Actually, we are building again a thick client, a thin client, everything on top of the sensors software that we have built before. The idea, and you can see this on the buttons and on the labels, that they are still placeholders, they're still not translated strings actually. This is because this is in development. But the idea is to have the 4 cameras tied to the sensors. So in case something happens, in case sensor 1 is triggered, you can order cam 1 to turn on and start recording. But the idea is that cam 1 can be the same as sensor, the same device, or can be a separate device. So let's say that someone triggers a sensor while entering a corridor, but you want the camera to be located at the end of the corridor. You can do so, and you can tie them together. That's the main idea, but it's still in development. But let's say that you want your camera to use its its internal sensor. Well, you can do that too. You can have these events being fed separately. A sensor triggers up and the camera turns on, or the camera itself using its sensor triggers up a recording. This is up to the pen tester, up to the red teamer about what his or her desires are. We can see that the quality of the camera is acceptable. It's not something that will go full HD, but it will get you along at least. It will get you going. And something that it's pretty experimental, but we are still insisting on it. We're trying to add AI, but we are still putting up a fight with this. But the idea still remains that maybe in a future release, or maybe in the first release, to be honest, we may be able to implement it. Now we'll have a real short demo, because this is not a finished product. And so far, this smaller part is the camera, properly set camera, and the part behind it's a power bank too. So we're trying to build everything together, and we can make it fit into a box. This is only an early stage. We are obviously not going to ship a product like this, but it's still something that we are playing around with, and we will be more than happy to bring up maybe in a next event here at ROOTCON. This is a small draft of what it will be the 3D printed case. This is pretty simple, built on Plus, so there's nothing really outstanding. It's not so big either. This can be fit inside your fist, inside your hand. Now we'll jump into a really short demo to see how they work. Okay, time for the short demo. As you can see, we have here the cases and the in-testing product. We have here our main dashboard, where you can see all of the cameras and which can be activated on demand and also be controlled remotely using this client. These are the 4 ones with its 4 power banks. As you can see, the frame rate is not the best on the ESP32, but it's still something that may work and may be useful in certain cases. We will open a new tab, the remote controller. Now, with these remote controllers, which will have a better frame rate, but we still rely on local dependencies to be installed. So that's the difference between this thin client, this web app, and the thick client, which will provide a better frame rate, but you will definitely need a laptop. You will definitely be left outside if you use mobile devices for this. Now the idea is to start recording and keep this recording of these cameras in the laptop. The point is that, remember, our idea is to have them bind to a sensor. So whenever a sensor is altered, you can trigger these cameras. So far, we don't have the integration finished. So remember that this is just a demo. Here we have the different recordings. You can have not only recordings or screenshots, you can do a sequential screenshot in order to get the feeling of a recording, but while not taking so much disk space, without taking so much storage. So far, this is what we have on this product, but we are really looking to expand it. Obviously, it will be open source too. Okay, so this is our artistic concept of how it will look once we have finished these projects and have tied all of them together. But we are still a little bit far away from that. So for now, I think this is enough. And we are just running over the time, so I think it's time to say goodbye, sadly. So, time for the conclusions and questions and answers. Our conclusions are pretty simple. Once we have landed a foot on this new age of cheap embedded hardware, which is almost available for everyone, we have the chance to make infinite combinations and make it increasingly easy to create implements and hardware to our liking. Now, you don't live in the past where you have to search a lot for a specific piece. Now you can have everything inside a small board, and you can combine it with almost anything, and you can find almost any documentation online. So we have to take advantage of this. Now, if you combine this technology with open source software, which again gives you a wide spectrum of things, you have a lot of documentations, you have free libraries for almost everything in the world, you have a lot of new flexibility to create new hardware. Now, the final result is not only more economical, but you are extending the product's lifespan a lot, because you will continually receive updates and upgrades, and commercial hardware will often discontinue certain models, will likely stop supporting certain models, where you can still get a new hold on your own open source hardware. So take advantage of that. You can follow us on Twitter. Luis is Alarm182Luis and Mauro Eldridge, and our DC is DC54111. And you can follow us on GitHub, where you can find almost all of our projects there. Obviously, this work will be published here on the report, which you can see below. And if you have any questions, we are more than happy to answer them here on Twitter or on Discord. Thank you.